All right, so we need to do a review, and I know it says 5.5 through 5.7, but it's really just going to be 5.5 and 5.6. I took the 5.7 problems off. So if you need your notes, this is what they look like. 5.5a is this really big, long note packet. It has like 3 pages all stapled together. And then 5.6 was on your own paper. So grab those two. Maybe pause it, take some time to make sure you have those, because I'm going to refer back to them quite often in this video. So on number 1 and 2, it says that we need to follow this same set of directions. So number 1 and 2, so for number 1, we're going to start with A, list the possible rational roots. This says list. So if you look over here, the rational root theorem helps us list all the possible rational roots. So how we do this is we list the factors of the constant term, which remember has no variable, over the factors of the leading coefficient, which remember is the number in front when it's in standard form. Then we split the list, putting a plus minus in front of each. And remember, a factor is a number that can be multiplied to get that answer. So when we start this, we want the factors of the constant term. So the constant term is this one right here, 12. Over the factors of the leading coefficient. So the leading coefficient is going to be the number in the very front. Now notice there's not a number there, so we can put in a 1, because if there's an x to the third, there's at least one of them. Okay, so factors of 12. What are the factors of 12? Well, if you look, they actually are listed on your note sheet. 1, 2, 3, 4, 6, and 12. Now, if you don't know the factors of a number, grab a calculator and just start dividing. So I would just do like 12 divided by 1. Okay, see that gave me a number without decimals, so I would put 1 down. 12 divided by 2. Again, number without decimals, put down a 2. 3 and 4 we both know work, so let's try 5. Okay, see 5 gave me a number with decimals, so that means I do not put 5 on my list. So see how 5 is not on the list? Because it doesn't give us a nice number without decimals. So that's how we get factors. If you don't know them off the top of your head, grab a calculator, start dividing. Remember, the little blue calculators are over on the counter. That's what you get to use. So we put those over the factors of our leading coefficient. Our leading coefficient is 1, so that is all that we have. Then we need to split the list and put a plus minus in front of each. So when we split the list, we take each number of the numerator and divide it by each number of the denominator and simplify before we write it on our list. Dang it. Sorry, motion sensitive lights, and apparently I haven't moved enough. So 1 over 1 is what we have first. 1 divided by 1 is 1. Then next we move over to the second number, 2 over 1. Well, 2 divided by 1 is 2. 3 over 1 is 3. 4 over 1 is 4. 6 over 1 is 6. And 12 over 1 is 12. So this looks like a nice little list, but remember these plus minuses each count as 2, because that's 1 and negative 1, 2 and negative 2, etc. 1, 2, 3, 4, 5, 6. So there are actually 12 possibilities here. But that's better than infinity, so that's good. B says, how many roots will this problem have? How many roots it will have is the same as the degree. So the degree is 3. So that is over here. A polynomial function has of degree n has n roots. So whatever the degree is, that's how many roots you have. So 3 answers. That means when E, it says find the actual roots, we have to find 3 answers. Next, it says find the possible positive roots. Well, to do the possible positive roots, we look at the signs. Okay, so this first thing is a plus. The negative 3x squared is a minus. The negative 4x is a minus. And the 12 is a plus. So we're looking at the number of times the sign changes. So plus to a minus, that's 1. Minus to a minus, that's staying the same. And minus to a plus, that's 2. So we have 2. But if you read in your notes, it says, we count the sign changes. It said there could also be 2 fewer, 4 fewer, or 6 fewer. So So subtract 2 until we get to 0, or we don't go to negative numbers. So 2 minus 2 is 0. Okay, 0 is as far as I go. So 2 or 0 is the answer on that one. Okay, next one is how many negative roots I would have. To do this one, we are going to sub -1 for all the x's and simplify, then count the sign changes. And if you remember our hint, down here, if there's an odd power, change the sign. If it's an even power, keep the sign. Okay, so this first one is x to the third. 3 is an odd power, so I'm going to change the sign. It doesn't have a sign, so that tells me it's going to be minus. Oh, there's not even a D on here. Sorry, you'll have to write this in. Okay, the next one, x squared, that's an even power, so it stays the same. The next one, -4x, there's a power of 1, so that's an odd power, so I'm going to change it. And this last one, the 12, doesn't have an x, so that means it's an odd power, so it will stay. So negative, negative, I only have 1 sign change. And if I subtract 2 from this, I'll get into negatives, so I don't go into negatives, so just 1. All right, so what this tells me is I have 2 positive, 2 or 0, and 1 negative. So since 2 is bigger than 1, I'm going to start with just positive numbers. So remember, you can pick any number from this list, any number at all. I feel like picking 2. No really rhyme or reason, just feel like it. And then we test using synthetic division. So remember, synthetic division, we do the coefficient line here. So there's 1x to the third, there's -3x squareds, there's -4x's, and then there's 12. We don't have any zeros because we don't have any placeholders. Okay, so we drop this first one, multiply by 2, add down, multiply by 2, add down, multiply by 2, and I get a 0, and that makes me happy. Why does that make me happy? Well, it tells me I found a root. So clear down at the bottom, when it says find the actual roots, down here, I'm going to write x equals, and then I'm going to put the number that I just found. X equals 2. Where did I get that 2? It was the number I picked in the box. Now, if you don't get 0 on your first time, that's fine. You might not. Pick a new number and test again. Okay, so now what I need to do is rewrite. So if I rewrite this, I have, this is the remainder, this is the number, this is the x, and this is the x squared. So I have x squared minus x minus 6. And you might notice that this is a quadratic. So since it's x squared, now we need to use the quadratic formula. Okay, so to use quadratic formula, we need to know what a, b, and c are, and they are actually right here. A is 1, b is -1, and c is -6. So we're going to do quadratic formula. X equals opposite b, plus or minus the square root of b squared. So -1 squared is 1, minus 4 times a times c, divided by 2 times a. So the first thing we do is this part in the underneath that square root. So 1 minus, and then I have -4 times 1, which is -4, -4 times -6, that turns this to a plus sign, and 24, okay? So count your negatives over here. If there's 2, this will change to a plus sign. If there's only this one, or if all 3 of these are negative, this would stay minus. So if there's only 1, it stays minus, or if all 3 are negative, it stays minus. If there's 2, it changes to a plus. So 1 plus 24 is 25. So I have 1 plus or minus the square root of 25 divided by 2. Well, hopefully you know that that the square root of 25 is 5. So I have 1 plus or minus 5 over 2. So I split this. 1 plus 5 divided by 2. 1 minus 5 divided by 2. You have to actually do each of these. You can't just do one and then think that the other one's going to be the opposite, because that's not the case. 1 plus 5 is 6. 6 divided by 2 is 3. So down here on my list, I'm going to put a 3. Then here, 1 minus 5 is negative 4. Negative 4 divided by 2 is negative 2. So negative 2 is my last root. So this, when it says find the roots, should have the roots, and it should be the number of answers should be the same as this in letter B. So it said I was going to have 3 answers. Did I find all 3? Yes. Now I can be done. Okay, so moving on to this next problem. I'm going to struggle a little bit with factors of 48. Okay, so we have to do the same thing. Factors of the constant. So factors of 48. So let's go 2 and 24. 48 divided by 3. 3 works. Okay, so 2 and 24. 3 and 16. 4 and 12. 48 doesn't divide by 5. 6 and 8. Let's see if it divides by 7. Nope. Okay, so 6, 8, 12, 16, and 24, and 48. Okay, so those are the factors. And again, I got those just by dividing using my calculator. So then I split the list. Remember, there has to be a plus minus in front of all of them. And this is kind of a lot. So hopefully we'll get lucky and pick a good one on the get-go. Almost couldn't fit them all in there. Okay. B next says how many zeros are there to find? Remember, that is the same as our degree. So 3. C, count the sign changes. Plus to a minus, that's a sign change. Minus to a plus, that's a sign change. Plus to a minus, that's a sign change. So 3. Or, I'm actually going to write those all out here. So we had 1, 2, 3 sign changes, 3 or 1. So that tells me that there's going to be 3 of these positive numbers that work, or only 1 of them that works. Negative sign changes, so D. Okay, remember odd powers, change the sign. Even powers, keep the sign. Odd powers, change the sign. No power keeps the sign. Okay, so if you look at this one, there are no sign changes. So that actually helps me a lot because this list is kind of long, but now I know I don't have to try any of the negative numbers. I don't care. They're not going to work. Okay, so on E, now I'm going to try to pick a number that's going to work, and I'm going to pick, I don't know, 2 worked last time. Let's try it again. 2. And I'm going to write small because I don't know how many things I'm going to have to test. Okay, so my coefficient line is 1, -3, 16, and -48. Okay, so 1, drop it down. 1 times 2 is 2. -1, -1 times 2 is -2. Plus 16, that's 14. 14 times 2 is 28. -48 plus 28 is not going to give me 0. So 2 didn't work. So let's try another number. 3. Let's try 3. And if you want to pick a different number than I'm picking and try it, that's fine. Like, I'm literally just testing these out of my head. We don't have any zeros because this doesn't have any placeholders, but remember to check yours and see if it does. Okay, so if I drop the 1, multiply by 3, 0, 0, 16. 16 times 3 is 48. Oh, look at that. Okay, so we are happy over here. How come we are happy? Well, because we found a root, because the remainder is 0. So this one, I didn't even do it. It would have been -20, correct? Hopefully I did that math right. So this one we don't like because that remainder is not 0. We want the remainder to be 0. So down here at the bottom, x equals, we know 3 is going to be one of our answers. 3. Okay, so here, now I rewrite this. Remember, this is the remainder, number, x, and x squared. So it is 1x squared plus 0x, so I don't have to write it, plus 16. And again, this is squared, so now we are going to use the quadratic formula. A is 1, B is 0, and C is 16. So x equals 0 plus or minus the square root of 4, or no, not 4, b squared, so that would be 0 squared, 0 minus 4 times 1 times c divided by 2 times 1. So remember, the very first thing we do is the math inside here. So we have 0 minus 4 times 1 times 16. So 0, and there's only one negative sign, so it stays negative. So we do 4 times 16, which is 64. So 0 minus 64 is negative 64. So I have x equals 0 plus or minus the square root of negative 64 divided by 2 times 1, which is 2. Okay. Now, if you remember, anytime we have a negative under the square root, that means we are going to have an I. So this is going to be 0 plus or minus the square root of 64 is 8. So I'm going to have 8. But remember, I had that negative, so there has to be an I. Okay, so 0 plus or minus 8i isn't really going to change that. So I'm just going to switch this around to be plus or minus 8i divided by 2. Okay, so can I divide 8 by 2? Yes, I can. So this is going to be plus minus 4i divided by 2. So 3, 4i, and oops, let me catch that mistake that I made. 8i divided by 2 is 4i. It wouldn't be divided by 2 anymore because I divided it by 2 to get the 4. So no more dividing by 2. So 4i and negative 4i. Now, this, when it's the same thing, only happens when this first number is 0. So over here, see how the first number is 1 and it became two different numbers? Over here, this first number is 0 and it was the same number, just 1 plus and 1 minus. Okay, so that's how you know when it's going to be the same number and when it's not. Okay, so that is all of those. And remember, I need to double check. Letter B said I was going to have 3 answers. Did I find all 3? Yes, I did. Okay, so now flip it over. 3 says, write a polynomial in standard form with the following roots. We do this one. Where is it? Yeah. So in your 5.5a notes, flip to the back of the first page, and this is the directions right here. To build a polynomial, when it says build a polynomial, it means in standard form. You have to first convert all the roots into factors and then FOIL. Remember, your tip is that you always have conjugates and to FOIL them together first, because the i's and square roots, if we have any, will cancel. Okay, so first thing we have is x equals 5. So I'm going to write it here, x equals 5. So in order to change that to a factor, or that is, yeah, no, that's a root. To change it to a factor, all I do is change the sign and put it in parentheses. Okay, here I've got x equals negative 3i. So to change that one to a factor, it's going to be x plus 3i. Okay, now those are the only roots that are given to me. But anytime you have an I or a square root, you have to remember the conjugates. It's kind of like remember the Alamo, but not as bloody. Remember the conjugates. So if I have any that have an I also have the same thing, but with a different sign in front of the I. So this was negative 3i, so its sign is negative. I change it to positive. Okay, so it's the same number and there's an I with it, but I just changed the sign in front of it. So this was x plus 3i. This one will be x minus 3i. Okay, and then remember that our tip was that we always want to FOIL the conjugates together first. So we need to FOIL these together first. And the reason for that is because that way the i's will cancel. So this x minus 5 thing, it'll just come on down. And we'll FOIL this. So we'll do x times x, because that's first. X times x, that's x squared. And then I have x times negative 3i. Since none of those can be multiplied, they all just sit next to each other. Negative 3ix. And we put the letters in alphabetical order. Okay? Then next I have positive 3i times x. Same thing. None of them are similar. I've got a number, an I, and an X, so not any of the same thing. So I just sit them all together, putting the letters in alphabetical order. And then last, I have 3i times negative 3i, so that's going to be negative. Now here I have two numbers. 3 times 3 is 9. And I times I, remember anytime you have the same letter times itself, it is I squared. Now, hopefully you notice that here in the middle I have negative 3ix and positive 3ix. Those are going to disappear because they are the same thing, one with a plus and one with a minus. There's also something interesting going on over here. I don't know if you remember or not, but I squared is negative 1. So really this term is negative 9 times negative 1. Well, a negative times a negative is a positive, and 9 times 1 is 9. So this term over here is going to get replaced with a positive 9. So my x minus 5 is still going to come down. My x squared is still here. Those middle two terms are canceled, and this one became negative 9 times negative 1, which turns into a positive 9 for us. Okay? Now, look, all your i's are gone, and that has to happen. And once that happens, then you can FOIL the remaining two and get your final answer. Now remember, we did do some super FOILing in a box, and so if you want to put it in a box, put one down the side and one across the top, that's fine. Since there's only two, they're both binomials, I'm just going to FOIL them. X times x squared, when you are FOILing, when you're multiplying and you have x and x squared, you add the exponents. So this has an exponent of 1. This has an exponent of 2. 1 plus 2 is 3. Then I have x times 9. So that's going to give me 9x. Then I have negative 5 times x squared. And then negative 5 times 9. And then I notice that these are kind of in a wonky order. They need to go from largest to smallest exponent. So I need to kind of switch them around. And there we go. That's it. So I have another couple of these for you to try, and I've left an answer key for you to check yourself when you're done. So go ahead and grab that other worksheet and get started. Good luck. Don't forget you have a quiz tomorrow.